Okay, so I'm going to do the notes with the video today, and you can listen to the video or not. Um, you're watching this, you're watching the video. So Darwin noticed three distinctive patterns in his biological diversity. First, species vary globally. So they had different yet similar animal species inhabited separate but similar habitats around the globe. What do we mean? Okay, so this is what we mean. Look at the ostrich, the rhea, and the emu. They look similar. They're all very large birds, but they're different. They're different species with similar habitats. They're found in different places around the world. Okay, so that is the first one. The second thing he noticed, species vary locally. Different related species occupy different habitats within a local area. So the Galapagos Islands have a lot of different turtles on them. So every island has a unique habitat. So the very large tortoises there, tortoises, all are unique depending on which island you go to. And there's the map of the Galapagos Islands. Thirdly, species vary over time. Some fossils of extinct animals were very similar to living species. So this is an extinct armadillo. It would be about waist high. As you can see, it's on a platform. It's about 6 feet long. Look at the armadillo today. It's maybe a foot long and, maybe 6 to 8 inches off the ground. But we know if we studied the bone structure, we can see a lot that they were indeed related to the ancient armadillo. So Darwin didn't pull out ideas from nowhere. He looked at other people and other things that around him. And two of the people were Hutton and Lyell, and they had figured out that the Earth was several million years old, at least, and that the processes that changed Earth in the past, millions of years ago, are the same processes that see today. And so Darwin saw that. He saw landslides and he saw volcanoes while he did his trip around South America there. Today we know the Earth is 4.6 billion years old, but Hutton and Lyell was on the right path as to the fact that Earth is very old. So, processes that changed the Earth. Earthquakes, which caused a landslide that Darwin saw. Meteorites hitting, volcanoes. Another scientist, Jean-Baptiste Lamarck, he said organisms could change during their lifetimes by selectively using or not using parts of their body. He also said acquired traits would be passed on to their offspring. So, like, if your dad is big and strong, you would become big and strong because your dad was big and strong. So, here's the difference between Lamarck versus what Darwin came up with over time. So, we had a giraffe that had a little bit of a long neck. And he kept stretching his neck because he had to reach higher and higher up on the tree to get those leaves. So his neck actually got longer just by stretching it out. And he actually passed on that longer neck to his offspring. Well, if that's the case, you could get taller by stretching your legs out by hanging upside down every night. If that's true. It's not true. Okay? So if we look at the Darwin, and Wallace is another person that came up with the idea of natural selection. You had a group of giraffes that had different length necks. Those that had the longer necks did better. They were healthier, so they had more babies, and their babies tended to have longer necks because the ones that had the longer necks survived better. And so after a long period of time, the longer necks were the more popular of the population, and you kept getting longer necks because that's the way genetics works. So, things that John Baptist Lamarck also thought, that organisms just became more perfect and more complex over time. We know this is incorrect. Evolution does not mean better, it means more fit for an environment. Okay. Malthus was a economist. He noted that people were being born faster than they were dying. Still happening today. We're at over 7 billion people at this point. He reasoned that the human population cannot keep growing forever, that we will run out of living space and food. Well, Darwin reasoned that this applied to other organisms even more so than it did to humans. And here's our world population growth for humans. There's a little dip here. That's the Black Plague. And then modern age. We understood what was causing death and disease. And yeah, we're way up here. To focus in on more modern times, your great-grandparents saw the 2 billion mark. Your grandparents, the 3 billion. Your parents, the 4 billion. You guys were born somewhere in this slide here. You guys hit the 7 billion. We're going to hit 8 billion real soon. Can we support 9 billion? We don't know. So a maple tree can produce thousands of seeds every summer. An oyster can produce millions of eggs every year. However, most offspring die before they reach maturity, and only a few of those that survive will manage to reproduce. These thoughts, paired with the evidence that he gathered while on board the HMS Beagle, led Darwin to come up with a theory, evolution by natural selection. What does it take for natural selection to occur? I want to double check where we are in the notes. We've covered all of this. The geologists, the biologists, Lamarck. Remember, Lamarck's theory is not true. The economist Malthus. Organisms that overproduce. Okay, so we are ready for what does it take for natural selection to occur. So you're going to have a 1, a 2, and a 3. Okay. And we are almost done. Just wanting to make sure I knew where we were at. Okay. So first of all, we need variation. And part of where variation comes from is the natural mutations that we have. 2, some of these variations that are there are better suited for life in that current environment, wherever that current environment is. Okay, so variation happens first, and then it's wherever the environment is whether or not those variations are good or not good. And 3, we need competition. In other words, there has to be a reason that some people survive or some organisms survive and some organisms don't survive as well. And remember, the best part of a video, you can pause if I'm going too fast and get these written down. Any heritable characteristic that increases the organism's ability to survive and reproduce is called an adaptation. So it could be that they can run faster. That wouldn't be an adaptation. They can jump higher. And a fitness describes how well an organism can survive and reproduce in that given environment, whatever that given environment is. Individuals with characteristics that are not well suited for that environment will either die or without reproducing, or they leave fewer offspring. They are said to have low fitness or lower fitness. The more an individual reproduces, the higher their fitness is said to be. Look, this is an example of horses, and so 50 million, 60 million years ago, they were very small, about the size of a large cat, 20, 25 house cat, that is 20, 25 pounds. And over time, they developed hooves. It wasn't until 25 million years ago that they had a true hoof. There's about 4 or 5 different types of horses about 7 million years ago. Some of them would have become zebras, donkeys, and then you'd have the true horse. So this one became the true horse. At this point, you can see that they have a real hoof. And then about 3 million years ago, you have the first actual real horse. And that is it for the notes for the day. That means you should have completed this. The horse wasn't anything that you had to write down. It was just a visual. Don't forget to turn them in, so I know that you were here for the whole thing. The only other thing you should have done today, make sure that you completed the pretest, and then we will be good to go for tomorrow. Thanks, guys.